Hi guys, in this video I will be talking about complex numbers. So far we studied real numbers, and whenever we solve a quadratic equation and we have a negative number under square root, we said that there is no real solution. For example, in the given function here we have x squared plus 1. If we are asked to solve this, we equalize it to 0 and we bring the number to the other side to isolate x, and we have square here. To get rid of square root, we take square root of both sides, so x becomes negative and positive square root of negative 1, which we have been saying there is no real solution. There is no real solution doesn't necessarily mean that there is no solution at all. It means there is just no real solution. So if there is no real solution, then there is a complex solution. Now I'm going to introduce you the new number of worlds. So here, the square root of negative 1 has a special name. Square root of negative 1 has a special name, I. We will call square root of negative 1 as I, which represents an imaginary number. So whenever we see square root of negative 1 in the question, in the result, we will rewrite this as I. The first part of the section is simplifying square roots of negative numbers. For example, let's take a look at, check it out 1c. So negative 1 over 3 square root of negative 63. So we will rewrite this. We will try to rewrite this as we have negative under radical. Let's write this as square root of negative 1 multiplied by square root of 63. Remember, in radicals, multiplying radicals, if you have a by b under radical, you can rewrite this as square root of a by square root of b. You can do this, you're allowed to do this. So we are using the same property here. We can rewrite negative 63 as negative 1 times 63. So under radical you have negative 1 times 63, which you can separate it as square root of negative 1 by square root of 63. How about 63? Can I rewrite 63? Yes, I can. I can write this as product of a number and a perfect square number, like 9 by 7. I cannot take 7 out of radical, but I can take 9 out of square root. How do I do this? Square root of 9 is going to be 3, but square root of 7 will stay as it is because it's not a perfect number. I can't take it out. What about square root of I? I just learned that square root of negative 1 is called I, so I'm going to write I instead. And in front, I have negative 1 over 3. So here I have 3 at the bottom, 3 at the top, which can cancel each other. I will left with negative square root of 7i. You can also write negative I times square root of 7, but it's better to use the letters at the end, numbers in front. So this is the simplest form of this given complex number, negative square root of 7 times I. So whenever we have a negative number on the radical, we always write this in terms of I. This was the first part. Second part, solving quadratic equations. Let's take a look at, check it out to see. Here I have 9x squared plus 25 equals 0. Bring 25 to the other side. I have 9x squared equals negative 25. And get rid of 9 by dividing both sides by 9. 9's will cancel each other. I have x squared equals negative 25 over 9. To isolate x, get rid of square root, not power 2, by taking square root of both sides. So x becomes plus and minus negative square root of 25 over 9. As I did in the previous question, I will rewrite this negative 25 over 9 as negative 1 under radical times square root of negative 25 over 9. So here I have square root of negative 1, which is called as I. And I know what square root of 25 is. It's a perfect number, which is 5. And I also know what square root of 9 is. That is 3. Remember, one more note. If there is a over b under radical, you can rewrite this as square root of a over square root of b. So I can write this as square root of 25 over square root of 9. So I can take square root of 25 alone as 5 and square root of 9 alone as 3. So what do I have? I have plus and minus I multiplied by 5 over 3, or 5 over 3 multiplied by I. I prefer to write I after the number. So that's our solution. What kind of solution we have? It's not real solution, but it is an imaginary solution. So what does it have to do with complex numbers? Let me explain what complex number is. Complex number is a number that can be written in the form of a plus bi. A is a real part, b is an imaginary part. So every complex number has a real part or an imaginary part or both. Complex number, the real numbers are subset of complex numbers. Imaginary numbers are also subset of complex numbers. We can call real numbers as complex numbers, imaginary numbers as complex numbers too. And by adding or subtracting them, by combining them, it is also a complex number, which can be shown as using capital letter C, and there is a straight line here inside C. So the real part, the part that has no I in it, imaginary part, is coefficient of I. We have some questions that are asking about the unknown, the variables, when two complex numbers are equal to each other. So whenever there are two complex numbers equal to each other, we have to know that their real parts are same and their imaginary parts are same. So for such questions, we will equalize the real parts and imaginary parts. So on the left, we have 2x. On the right, there is negative 8. So they are the real parts. There are no i's in it. So we equalize them. 2x equals negative 8. Divide both sides by 2. X is negative 4. Similarly, on the left, we have negative 6, coefficient of I. On the right, 20y is coefficient of I. Not just 20, not just y. 20y together is the coefficient of I. So we equalize those two to each other by using this negative 2. Don't forget, there is negative in front of 6. So we also have to use this. So equalize imaginary parts, which are negative 6 and 20y. No need to write i's. I's will cancel each other. You just take the coefficients. We are going to learn how to find complex zeros of quadratic functions. So when you try to factorize it, let's try. You factorize it as xx, 13, 13 and 1. There is no other factor for 13, just 13 and 1 is the prime number. So x times 13, 1 times x, which makes 13 and 1. When you add them up, it gives you 14. So as a rule, adding those two should give you the middle term. Your middle term is 4x. When you add this up, you get 14x. So this factorization method doesn't work here. So I cannot factorize it. This equation can't be factorized. So we should use another method. In grade 10, you used another method for questions that cannot be factorized, which is called completing square method. Let me explain this method. I'm sure you forgot, but I will remind you. So first of all, you equalize your quadratic equation to 0 to solve it. X squared plus 4x plus 13 is equal to 0. And let's bring the constant number to the other side. Rewrite this as x squared plus 4x equals negative 13. So I'm going to complete the square to make this left side perfect square trinomial. To do so, I'll take the middle term, coefficient of middle term, which is 4, divided by 2 and square it and use it as a third term on the left. So remember, by adding or subtracting something to the equation, to keep the balance, whatever you are adding or subtracting to the left side, you have to do the same on the right side. I need to keep the balance. So what is 4 over 2 squared? It is 4. So I have x squared plus 4x plus 4 equals negative 13 plus also 4. So what do I get here on the left? On the left, I got a perfect square trinomial, which means when I factorize this, x factorize 4, 2, 2, x times 2, x times 2, 2x plus 2x makes 4x, gives me the middle term. So you can factorize this as x plus 2 times x plus 2, which is x plus 2 squared. So x plus 2 squared. On the left, I have x plus 2 squared. On the right, negative 13 plus 4, I get negative 9. Now my equation is simpler. I'm gonna isolate x by taking square root of both sides first. 2 and the radical will cancel each other. We have x plus 2 on the left, on the right, plus and minus square root of negative 9. Remember from the previous questions, whenever there is negative on the radical, you rewrite this as negative 1 times 9. You know what negative 1 under square root is. This is known as I. You know what square root of 9 is. That is 3. So you have plus and minus 3i on the right, on the left, x plus 2. I still cannot get x by itself. Bring 2 to the other side. So x becomes plus and minus 3i. I'm going to reorder it. And bring 2 to the other side, negative 2. I have a real number here, an imaginary number here. Real and imaginary together is a complex number. So we have complex solutions. My solutions are negative 3i minus 2 and positive 3i minus 2. I have two complex solutions. They are not real, they are complex numbers. Finally, we will be talking about the conjugates, finding complex conjugates. To find the complex conjugate, all we have to do is change the sign of I. For example, check it out 5a. What's the complex conjugate of this? You keep the real part as it is and change the sign of imaginary part. Imaginary part is negative I. When you change the sign, it becomes positive I. It's that simple. Here in B, the sign of I is positive. Make it negative to find the conjugate and keep the real part as it is. Real part will same. There is no real part here. Change the sign of imaginary part. Negative becomes positive. So that's how you find the complex conjugates. We're going to use complex conjugates to simplify complex numbers.